These are the notes for section 2.6. We're talking about the graphs of rational expressions. Up to this point, we've talked about how to simplify and solve them. Now we're going to look back at the graphs. Some of this is a review of some things that you talked about in chapter 1. So first, domain. We've talked about domain, and it's all possible input values that have an output. Recall the denominator cannot equal 0. So if we find the domain for each of these examples, in our first example, we know by looking at the function that the denominator can't be 0. And we know that x equals 3 is going to make the denominator 0. So that is an input that is not possible. It will not have an output. So the domain of my function is from negative infinity to 3, and I'm not including it, so I use a parenthesis, and then 3 to infinity. You can also look at the graph, and you'll see that you'll have an asymptote here. In the second example, we need to factor the denominator in order to figure out which values are going to cause us problems. So we end up with x plus 5 times x minus 1. Here, I need to leave out negative 5 and positive 1. So these values cannot be in my domain. Can't have them. So my domain becomes negative infinity to negative 5, leaving it out. Then, I'm also going to have values from negative 5 to 1, as well as 1 to infinity. Notice in both cases, I use parentheses instead of brackets because I'm not including these values. The next thing we're going to look at is x-intercepts. And you dealt with these as well earlier. We called them the zeros when we talked about them in section 2.1 to 2.4. So we're going to look at the graph and we figure out where points where the graph crosses the x-axis. The other way to do this is look at where would my numerator equal 0. So by looking at the graph and using my Desmos, I would find that there is a point 0, 0, and that's where the graph crosses this axis. So I can also take my numerator, 2x squared, and set it equal to 0. Here I get x squared equals 0, so I found out that x equals 0. And I get the same answer. My x-intercept is the point where the graph crosses the x-axis. Make sure you understand, since it's a point, I need to write my answer as 0, 0. So here's an example. Find the domain and intercepts of the function. I've given you a portion of the graph. You can also graph this on your own Desmos. And we would see that my x-intercepts happen at x equals 2 and x equals 3. So my intercepts are 2, 0 and 3, 0. But to look at my domain, I need to look at the denominator. In my denominator, x cannot equal 6, because that would make it 0. So my domain is negative infinity to 6 in union with 6 to infinity. And the domain and the intercept should be a bit of a review, but remember, you can always look at your graph. If you still have questions over these concepts, make sure you're asking them. The third thing we're going to talk about today are asymptotes. Asymptotes are lines on a graph that the function approaches as it extends to positive and negative infinity. In most cases, the graph is going to approach this line and never touch it. Once in a while, the graph will cross the line, but then as it gets really, really big and it extends out to infinity or negative infinity, it will never touch the line again. Vertical asymptotes occur where the denominator equals 0 and have the form of x equals c. So remember, vertical asymptotes are x equals. Horizontal asymptotes are a little bit more difficult. We have 3 rules for those. If the degree of the numerator is less than the denominator, then the line y equals 0 is an asymptote. If the degree of the denominator is smaller, then there are no horizontal asymptotes. And if they're the same, we take a look at the leading coefficients of the numerator and the denominator, and they become our answer. Let's look at an example. Find the domain, intercepts, and asymptotes of the function. Well, my domain, notice, 0 is the only thing that it won't get an output on. So negative infinity to 0 and 0 to infinity. My x-intercepts, if I look at my graph, or I look at my function and where is it going to be 0, I get the answer. In this case, my only x-intercept happens at negative 1. So negative 1, 0 is my x-intercept. And I did that by looking at my graph. You can graph this on your Desmos and check that out. And I need to look at my asymptotes. Here, I have no horizontal asymptotes. The reason for that is because, according to our rule, the denominator is smaller than the numerator, so there are no horizontal asymptotes. Vertical asymptotes are going to happen where my denominator equals 0. So I have a vertical asymptote at x equals 0. And there you've answered your question. Here's another example. Notice in this one my denominator will not factor. So I'm simply relying on looking at the graph. And I look for my domain. In this case, my denominator will never be 0. So my domain is negative infinity to infinity. My x-intercepts. Now, it's easier to take a look at horizontal asymptotes, actually, because we notice our denominator is bigger than our numerator. So this means the line y equals 0 is an asymptote. Which, in looking at our graph as well, we notice that the graph's never going to cross the y-axis, because y equals 0 is an asymptote. So there are no x-intercepts. Also, our denominator can never be 0, so we have no vertical asymptotes either. Let's look at another example. Here, my numerator and denominator have the same power, x cubed and x cubed. So my horizontal asymptotes is going to occur at y equals 3 over 2. Because these are my leading coefficients, and I take a look at the 3 and the 2. Vertical asymptotes are going to happen at x equals 0. Because 0 is going to make the denominator 0. So that tells me in my domain, I leave out 0. And now I need to look for x-intercepts. My numerator is going to equal 0 when we see our x-intercept is at negative 2.15. We did this by looking at the graph. Let's move on to the next example. I'm going to let you do this first student example. Please pause the video now, do the example, and check your assignment. Please check your answer. If you looked at the graph, you would notice that at the point 0, 0, it actually says undefined. So that point is not included in our domain, but because it's just at that one point, it's also not a vertical asymptote. So we have no x-intercepts. We only have the two asymptotes at negative 1 and 2, and we have a horizontal asymptote at y equals 0. Go ahead and attempt this example. Pause the video, and then come back and check your work. Here are the answers for this example. Check your work. In many cases, you're going to go to the graph to try to figure these out, especially if you're not able to factor the denominators. Final example. Go ahead and pause the video. and come up with your own solutions.
I used to know them like.
Check your answers to the problem. When you're finished checking your answers, you can go on to your homework on page 245. Notice there are 3 different parts, and you need to do all of the odds in all 3 sections.